All right. Welcome you back, ladies and gentlemen watching. I promised you that I'm going to come with a lesson about integration of the trigonometric functions that involve odd powers. So we are going to look at how odd powers are dealt with. Right. We're going to see how odd powers are dealt with. The trigonometric functions I'm trying to talk about involve sine x, involve cos x. We're going to integrate functions involving tan x, involving cot x, involving sec x, involving cosec x. However, these ones here, their odd powers are looked at under integration by parts. So I'm not going to handle this. We are going for these two, a sec and a cosec. We are going to look at them when we start integration by parts. So I'm going to calculate numbers that involve integrating these functions that have gotten odd powers of sine, cos, tan, and cot. Reminder is that here we are totally going to use Pythagoras trigonometric property, where we are going to handle use cos squared x plus sine squared x is 1. We need to really know that 1 plus tan squared x is 1 is a sec. We need to know that 1 plus a cot square gives us a cosec square. And without wasting any time, let's begin with examples. I'm going to begin with the integral of cos power 5 x dx. The moment you see power 5, simply know that this is our odd power, being a 5. 5 is an odd number. So when you're integrating such, we need to really know that this is the same as integral of cos power 4x times cos x, of course, dx. So this is the same as cos squared x, then squared, then times cos x dx. However, this step 1 can leave it, but the fact that we are starting, we need it. So this is the same as the integral. This is the same as the integral. Our cos square is the same as 1 minus sine squared x. Using this property 1, we can make cos square x the subject, but everything squared, then times a cos x dx. Interestingly, this is going to be equal to, we can try squaring this, so it is going to be integral of, we can square and enter the cos, so it is going to be cos x minus 2 sine squared x cos x plus sine power 5x cos x, everything dx. Looking at this, is going to reduce to, when you look at cos x, when you integrate it, you get, so we shall have sine x minus here, we shall increase the power by 1, so it will be 2 over 3 sine cubed x plus 1 over 5 sine power 5x plus a constant of integration. That is not enough. Let's integrate a cos cube of 2x dx. Cos cube is the same as cos 2x times cos square 2x dx. So this is going to be, we can express cos, this cos in terms of sine. All right. I beg your pardon. Let me have it as the integral of sine cubed sine cubed 2x dx. So this is the same as the integral of sine squared 2x then times sine 2x everything dx. So here we can, sine squared is the same as 1 minus cos squared 2x, and then sine 2x everything is dx. This is the same as when you enter, it's going to be integral of sine 2x minus cos squared 2x cos squared 2x then sine 2x everything dx. When you integrate this one here, it's going to be negative a half cos 2x, right? Then here we shall have plus a half and a third, because this would be cos cubed, so it will be a third cos cubed 2x plus a constant of integration, which can be written as 1/6 1/6 cos squared 2x minus a half cos 2x plus a constant of integration. Maybe I can do you some other example. And do some other example. Under this example, we can consider the integral of tan cubed x dx. This is the same as tan x and tan squared x dx, which is the same as the integral tan x tan squared, the same as x squared x minus 1 dx, which is the same as the integral of tan x x squared x minus the integral of tan x itself dx. Here we know, when you look at this one only from the summary I gave you in the previous video, we know that when you differentiate tan squared x it gives 2 tan x squared x. Implying that when we integrate tan x squared x dx, it will give us a half tan squared x, implying that our integral of tan cubed x dx will end up reducing to the whole of this will be a half tan squared x plus, when we integrate tan, it is a negative ln cos x, but there is this negative which will make it ln cos x plus a constant of integration. So for this case, you will have done the integration of odd powers. You will have done the integration of odd powers. Let me see if I can do you more questions. And we see how we can fix them. All right. Let me see if we are to integrate a quote tube. If you're given integration quote tube x dx, this is the same as the integral of quote x quote squared x dx, which is equal to the integral quote x into the quote square is the same as cosec square x minus 1 dx. And this is the same as the integral of quote x cosec squared x dx minus the integral of quote x dx. If we consider this one only for quote x cosec square x dx, I can take you through this briefly. We can let u to be quote x, so that our du, when you differentiate both sides, this one will be negative cosec squared u du. No. Cosec squared x dx. So that my dx itself only is going to be negative du out of cosec squared x. So that my integral becomes u cosec squared x times negative du over cosec squared x. These ones will cancel, so that you have the integral of negative u du, which is the same as negative u squared out of 2. But u is the same as cot, so it will be negative cot squared x out of 2, which is the same as negative a half cot squared x, which is the same as also a half. Of course, a cot is the same as cosec x minus 1. And we have already seen that when we integrate a cot, we get negative cosec squared x, or one can also write ln sine x, but we are going to go with this. Whatever. So it implies that our integral of quote cubed x dx is the same as negative a half cot squared x minus ln sine x plus a constant of integration. As simple as that. That is how easy life can be if you sit down. Further, we are going to have some more example. We are going to have some more example here so that we get what to do. I can give you the details. I can give you the exercise in the due course. So let's do one more example. And then we see if you can do some exercises by yourself. Let's integrate sine cubed 3x dx. This is the same as sine 2. It's the same as sine 2x times sine squared 2x dx, which is equally integral sine 2x 1 minus cos squared 2x from the Pythagoras formulas. Now for this case, you realize that if we let maybe our u to be cos 2x, it means that our du will be, when we differentiate cos 2x, we get negative 2 sine 2x dx. So that our dx is negative du out of 2 sine 2x, implying that the whole thing will be the integral sine, it will be sine 2x to 1 minus u squared times du negative over 2 sine 2x. Sine 2x will cancel with the sine 2x, so that you have the negative a half integral of 1 minus u squared du. And this one can be equal to negative a half. When you integrate u, you get u. When you integrate 1, you get u. Then minus u cubed out of 3 as a constant. But then we have to substitute for the value of u, so it will be negative a half u first anyway, plus u cubed out of 3, then plus a constant c, which is going to be negative a half, but u is cos 2x plus cos 2x anyway cubed out of 3, then plus a constant of integration. That is how you can do that question. Let me do the last question. order second last so that you master this work very well. If we integrate cos power 5 of 3x dx, one can say that this is the same as cos 3x times cos power 4 3x dx, which is the same as the integral of 3x. I can exploit that further. Cos squared 3x then squared dx, which is the same as cos 3x into 1 minus sine squared 3x by Pythagoras, then squared dx. If we let our u to be equal to sine 3x here, so it means that our du is going to be 3 cos, when you differentiate, cos 3x dx, implying that my dx is going to be du over 3 cos 3x, implying that overall is going to be integral cos 3x into 1 minus u squared then squared times du over 3 cos 3x. Cos 3x will go with cos 3x, so that I remain with a third, if I factorize out a third integral of 1 minus u squared, then everything squared. Of course, du, this is going to be equal to a third integral of, if we expand this, it's going to be 1 minus 2u squared, of course, plus u power 4, then du, which is the same as a third. When you integrate 1, you get u, and there you get 2u cubed over 3, then plus u power 5 over 5, of course, then plus a constant of integration c. But we need to put what u is equal to. U is sine 3x, so we shall have sine 3x here, minus 2 sine cubed 3x out of 3, then plus sine power 5 3x out of 5 plus a constant of integration. Multiplying inside, it will be a third sine 3x minus 2 out of 9, because it will multiply here, but then sine cubed 3x plus sine 5 3x over, if you multiply with the 5, it becomes 15 plus a constant of integration. As simple as that. I feel like doing more, but let me do one more. I'm enjoying these things here. Let me do one more. What if we are to integrate cos squared x over 2 sine cubed x over 2 dx? This is the same as cos squared x over 2 sine x over 2 sine squared x out of 2 dx. This is the same as cos squared x over 2 sine x over 2 1 minus cos squared x over 2 dx. If I let u to be cos x over 2, my du would be negative a half, because the angle is a half, negative a half sine x over 2 dx. So that my dx is equals to, my dx is going to be equal to negative 2 du over sine x over 2, implying that the whole integral is going to be, I let u to be cos x over 2, so it will be u squared, then sine x over 2 into 1 minus u squared again, times dx, which is negative 2 du over sine x over 2. Sine x over 2 and sine x over 2 will cancel, and I will have negative 2 outside, integral of u squared minus u power 4. I multiply du times 1 u squared times u squared, u power 4 du. So this is going to be negative 2u cubed over 3. All right, then plus when we multiply a 2, it will be plus 2u power 5 over 5. You increase the power by 1, u power 5 over 2, or rather over 5, then you multiply negative 2. It will be that. So plus a constant c. It's going to be negative 2 over 3 cos x over 2, then cubed, because u is cos x over 2, then plus 2 over 5 cos x over 2 to the power of 5 plus a constant c, giving me negative 2 out of 3 cos cubed x over 2 plus 2 over 5 cos 5 x over 2 plus a constant of integration. Go through, like, subscribe, and share the link all over. Thank you for listening. Have a great time. Now, our next section will be integration that involves sine and tan substitution. See you there.